This question took a lot of students by surprise in their Maths A level. In fact, students who got the first part of Part B correct frequently lost all of the marks in Part 2. Let's see why. In their report after the exams, the examiners said that this was a more demanding than expected question on geometric sequences. They said that the second part of Part B proved to be very challenging for many candidates. It was very frequent that those who had correctly identified the correct value of k in Part 1 of Part B did not show their working to find the values of a and r, and therefore lost all of the marks in the second part of B. Let's have a look at it. It says the first three terms of a geometric sequence are given as follows, where k is a constant. We're asked to show that k satisfies this equation for 2 marks. So we're asked to show where this formula comes from. It's not asking us to solve it, it's not asking us to find out what k equals, it wants to show how we get to this formula. So this is a geometric sequence. This is our first term, we call it a. This is our second term, we call it ar. That's because each time in a geometric sequence, we multiply by a common ratio r. So if we multiply again by r, the third term would be ar squared. So how are we going to get this equation? Well, we're going to use the fact that each time we're multiplying by the same quantity. In other words, if I divide this second term by the first term, if I divide ar by a, I'd get r. And similarly, if I divide ar squared by ar, if I divide the third term by the second term, again, I'd get r. So I'm going to use that fact here. So we've got ar, that's this, divided by a, that's the first term here. That would give me r. And in fact, that would be the same as dividing the third term, ar squared, this, by the second term, ar, which was this. If you get that far, you get your first mark. Next, we can rearrange this equation by multiplying both sides by this and by this at the same time, effectively cross-multiplying to eliminate the fractions. If you do that, we get this equals this. Next, expanding the brackets, remembering this is really hidden double brackets, you'll get this. And again, expanding the brackets on the right-hand side, you get this. Bring all the terms onto one side to get 0, and then notice that all of the coefficients here are all in the 2 times table. So we divide everything by 2, and we end up with the answer that we wanted. Next, it says, given that the sequence converges, find the value of k, giving a reason for your answer for part 1. We started in part A by showing that this equation was true. We can actually factorize this as follows, and therefore solve to find 2 possible values of k. Either k is 2/3 or k is 20. That gives us our first method mark. So we need to decide which of these 2 values of k is valid, because notice it says in the question, find the value of k, not the values of k, just one. And we need to explain which one it is, with a reason. We're told that the sequence converges. So that means that it must be that the common ratio r is between 1 and -1. In other words, its size, its magnitude, or its modulus, is less than 1. So, if k is 2/3, let's start with that, well, we can work out what r is. Remember, r we can get by dividing the second term here by the first term here, and that will give me r. So if we substitute in the value of k equals 2/3 into that, we end up with this, which simplifies to 5/3. But that's 1 and 2/3, so that's bigger than 1. It's not between -1 and 1, it's too big. So the sequence wouldn't converge for this value of k, in fact it would diverge for this value of k. So we can reject this value of k equals 2/3. We still need to show that k equals 20 leads to convergence though. So if k equals 20, again, substituting into this expression here, this equation for r, we end up with this, which simplifies to -3/4, and that is between -1 and 1. That has size less than 1, magnitude less than 1. So we can say, because that's true, it must mean that the sequence would converge for k equals 20, and therefore k does equal 20. Make sure you make your answer really clear for the final mark. Let's look at the second part of part B. It says find the value of the sum to infinity. So what do we know? Well, we know k equals 20, and therefore we can work out what the first term is. Remember, that's what we call a, that was 3k plus 4. So 3 times 20, that's our k value, plus 4 gives us 64 for a. And previously we knew that when k was 20, we worked out that r was -3/4. So we can substitute both of these quantities, a equals 64 and r equals -3/4, into the sum to infinity formula, which you should learn off by heart. That's a over 1 minus r. So substituting a is 64 and r is -3/4, being careful about the minus that we have here. If you do the number crunching, you end up with 256/7 for your final mark.